let's learn the significance of thermochemistry. Today, we discuss the first and second law of thermodynamics. So, what is thermochemistry? Thermochemistry is the study of heat, energy, which is associated with chemical reaction and or physical transformation. Chemical reaction can be absorbed of energy from the surrounding. This is what you call exothermic reaction and release of energy in the form of heat to the surrounding. This is what you call endothermic reaction. We need to remember the study of energy or heat changes can be involved the chemical reaction. It is the thermochemistry involved with quantities of heat and work. The unit is joules, which is the unit of energy. Now, let's move on to the first law of thermodynamics. Before that, what is thermodynamics? Thermodynamics is a study of relation between heat, work, temperature, and energy. The first law of thermodynamics says that heat energy cannot be created or destroyed and can only be transferred to one form or other.
Thank you, Christian. Now we go to the next example. We know plants sustain themselves through photosynthesis. However, do you know that this process is also an application of the first law of thermodynamics? The plants absorb the solar energy from the sun before converting the solar energy into chemical energy. Not only does this process nourish the plants, but it also produces oxygen, which is essential for our survival.
Enthalpy of chemical reaction, known as the heat content, the energy transferred under constant pressure. Exothermic reaction, this is when the heat is released. Exothermic reaction releases heat to the surrounding. For example, burning of wood, roasting of iron, and cooking of egg. Endothermic reaction, heat is absorbed. Endothermic reaction absorbs heat from the surrounding. For example, photosynthesis, melting ice, and dry ice.
The second law of thermodynamics states that the state of entropy of the entire universe as an isolated system will be always increased over time. The second law also states that the changes in the entropy in the universe can never be negative.
So now, we will be moving to the second law of thermodynamics and their statement. Here we have three statements. First statement, cautious statement. It says here that it is impossible for any system in such a way that the sole result will be an energy transfer by heat from a cooler to hotter body. Second statement, we have Kelvin-Planck statement. It says here that it is impossible for any system to operate in a thermodynamic cycle and deliver a net amount of energy by work to its surroundings while receiving energy by heat transfer from a single reservoir. And the last statement is entropy statement. It is stated here that it is impossible for any system to operate in a way that entropy is destroyed. High to low. For any process, a natural flow will always be from higher energy value to lower energy value. So we will be giving you two examples. Please discuss the two examples.
For example, coffee. The temperature of coffee is higher than its cup, and as what it says, from higher energy value, so the temperature of coffee gets transferred to the cup, which is cooler. We will have a lower energy value, and that's why the cup gets hotter.
Try a compressed gas air in a balloon. If you open a small hole in a balloon, does the outside air enter the balloon? No. Instead, the gas in the balloon goes outside, transfers its pressure to the outside air because the gas in the balloon has higher temperature than the outside air.